For now and in the future among speakers and participants. On behalf of the Faculty of Engineering at Mahidol University, I would like to thank Evelyn Gale, Tamayo, Dr. Mushtaq Ahmed Memon, Associate Professor Wongpan Lipaseni, Associate Professor Dakan Praphat, and all staff for their hard work in organizing this seminar. Finally, I wish you all every success this event. I hope that the virtual seminar on clean air solutions I wish you all a fruitful time and look forward to seeing you at our next academic event. Thank you very much. Hope to see you all again. Thank you.
Thank you very much, Dr. Chakrit, for the very nice opening speech. So our seminar will have like 4 presentations and end up with question and answers. So all participants, please kindly keep muted, and then when people have any question and answer, we can have via chat box, and we will have also question and answer sections. So I would like to invite our first speakers, Evelyn Gallo Tamayo from Clean Air Asia. So Evelyn is Clean Air Asia's air quality specialist, and she has been like working for 7 years to be and having combined experience in air pollution monitoring, emission inventory, health impact assessment, and the use of data analysis and capacities building to inform policy development to improve air quality. Evelyn plays a key role in like development and implementation and review of air quality activities, as well as like project of Clean Air Asia by providing technical guidance in current and emerging air quality issues in the region. So she has also a master's degree in environmental science from Institute of Environmental Science and Meteorology of University of Philippines, and received training from World Meteorologist Organization, Global Atmosphere Watch, and European Research Course on Atmospheres. So welcome Evelyn to give speech on air quality monitoring, emission inventories, and health mapping toward clean air action plan in Manila. So welcome.
Thank you very much, Dr. Prapaspongsa, for that introduction. And of course, thank you very much as well for having Cleaner Asia with this event. Thank you, Dr. Susakorn, for as well leading the Faculty of Engineering into organizing this event. And of course, good afternoon or good morning to all our participants and to our fellow speakers. I am now sharing my screen, and today, on behalf of the Clean Air Asia team working on the Asia Blue Skies program, I'm going to share about the highlights of what we have done in the city of Manila, focused on the air quality monitoring, emissions inventory, health mapping towards clean air action planning. So here in the presentation slides, I will first focus on giving an overview for those who have not worked or have not known Clean Air Asia yet. We are an international nonprofit NGO, and our main focus of action is not only on air quality and climate change, but also on sustainable transport and green freight. And we work on 3 main focus points, which is to inform for action. So we also do data analysis, we collect them, we visualize, and we use the data in order to create knowledge products and make sure that these are used to increase awareness. Aside from this, we make sure that our partners are learning from us. So we take pride in ensuring that there is capacity building. What we want to focus on is that our partners learn from each step that we do, so that even after the project or the program, they can do the processes on their own. And very important, of course, is that all of the analysis that are done are actually put into concrete action through policy development. So we work with governments at the local and national level, and even with communities to ensure that these actions are institutionalized. We have extensive work across Asia. These are just some of the key activities that we have done in different countries in Asia. And today we're going to focus on the city of Manila under the Asia Blue Skies program. So we do an extensive work on air quality monitoring, emissions inventory, dispersion modeling, and we also focus on air quality communication, governance, and even financing on how do we fund, how do we secure resources for air quality management projects. So here you see that the focus would be the discussion on Asia Blue Skies program. So this is actually a 5-year program funded by 3M, a private industry, and it actually is being implemented by Cleaner Asia in India and in the Philippines. Now, for this talk, we're just going to focus on the city of Manila with the overall goal that what we want is to improve air quality in the city, make the city of Manila a healthier, more livable city. As we mentioned, we always make it to a point that when we do projects, it has to be institutionalized. The actions should be really embedded with the actions that will be performed by the governments. So when we started the project, we first accomplished a memorandum of understanding to formalize the partnership with all the stakeholders involved. So that's the city of Manila and of course 3M. So the pictures that you are seeing here are from the signing of the MOU. So that's we have representatives, of course, from 3M, from our Deputy Executive Director, and the Mayor of City of Manila, Philippines. Aside from this, we also ensured that there would be institutionalization of the participation of the city personnel themselves. With this, the mayor signed an executive order establishing an interagency group that will be focused on air quality management in the context of the Asia Blue Skies program and all the other activities that can happen in the future because of the partnership. So this is just a copy of the memorandum identifying who the members are. So this ensures that the participants, that the representatives from different city offices will participate in the project. Here you will see that this is the framework that Cleaner Asia is implementing when we do our project. So this is called the Guidance Framework for Better Air Quality in Asian Cities. And it's based on the idea that everything that we do should have a solid knowledge base. This includes having knowledge of what's the level of pollution, what are the priority sources, what are the impacts, and all of these information are used to develop solutions. The solutions can be at the national, local, or at the individual level. But what's important is that we institutionalize it through a clean air action plan. And what we also do, we integrate it with the climate change action plan. So we call it the Integrated Air Quality and Climate Change Action Plan. So in the context of the city of Manila, similar to all efforts that we are doing on air quality, the main motivation, of course, is its impact on health. And here you would see figures from the latest State of Global Air. We're seeing that in 2019, as much as 7 million premature deaths can be attributed to combined air pollution. We're seeing even more grim numbers in terms of impacts, wherein if you look here, even 20% of neonatal deaths can be attributed to exposure to air pollution. The burden is borne mostly by people in the age group that are on the older age group, but also for those that are in the young or neonatal age. So from babies up to children to 4 years old. And definitely, this is more than enough to motivate us that we should do something about it. In the context of Manila, one of the first things that we did is to map, so to do a health mapping. And using data for the mortality and morbidity incidents in the city, we mapped the number of cases. So this is in 2019. in comparison to surrounding cities in the national capital region. And we're seeing that the city of Manila has high incidence of respiratory-related morbidity and mortality cases in comparison to their neighboring cities. And again, this is the respiratory health conditions are observed, especially among elderly and children. And you see here in 2018, 61% are cases that can be worsened due to exposure to air pollution. In 2019, it's even higher at 71%. So this just delves more closely on what kind of leading causes of morbidity were observed in the city of Manila. So in here, you can see 7 out of 10 cases are related, can be exacerbated by exposure to poor air quality, with acute respiratory infection leading the cases. By 2019, it's still the same thing. You have half of the leading cases that can be attributed to, that can be worsened by exposure to poor air quality. So another aspect that can be discussed when we are doing health mapping is to look at the costs, because this is the topic that usually gets the attention of the public and of policymakers, because of course, discussions on costs and economics is always an important aspect when developing policies and measures. We looked at the PhilHealth claim. So this is the national health insurance of the Philippines, and this gives us an idea of which cases have the highest claims. And majority were respiratory and cerebrovascular causes, again, can be worsened by poor air quality. In terms of costs, it ranges from 3 million to 81.5 million pesos. And definitely the message that we're trying to show here is that when we improve air quality in the city, it can lead to reduced cases or reduced worsened cases of these health conditions. And of course, that can also lead to hospital costs. Later on, we also quantified this, but I'll present more on that after the presentation of the monitoring and the inventory, emissions inventory. So definitely the case is there. The health data just reinforces and pushes that we need to urgently act on this. So to establish the baseline of air quality in the city, we perform air quality monitoring in different sites across the city. In the beginning, we had 3 monitoring sites, and it was first focused on a busy roadside near the city hall. Another one is in a Rizal Park, so it's an open green space with no near roads or no emission sources nearby. And another one, the Menjola site, which is a school zone. So this was in the beginning of 2020, so there was no lockdowns yet because of the COVID-19 pandemic. Eventually, we also added more monitoring stations as we recognize that there is a need as well to understand air quality in different sites in the city. We put additional sensors in heavy roadsides, so that's in the port area and in an intersection in Aurora. And we're also doing monitoring now in the indoor and outdoor environments of a hospital. So here in the right side is the map of the distribution of these instruments. And by the way, in one of the sites, there is a government reference instrument here in Mehan Garden. And this is where we have been collocating one of the sensors to ensure the quality of data that we collect using the non-reference sensors. So just to give an idea on this, we wanted really to make sure that before we use the data for the development of the Clean Air Action Plan, we are trying to ensure that it has the values are as close as possible to reference instruments. That's why from August 2020 up to now, the collocation of one of the sensors is still ongoing. It has acceptable correlation coefficient as based on the US EPA recommendation, performance recommendations. So just going back to the slide. Here you can also see the importance, and we always emphasize this, that it's very important that, of course, we have access to alternative sources of air quality data, alternative sources of data, but we have to make sure that the quality of the data is acceptable. So we have to perform QA/QC. This plot just emphasizes that we have to correct for the data, because so the dotted lines are the raw sensor readings, and we have to make sure that the data is corrected first. So the orange line is the reference instrument and the green line is the corrected sensor data. Doing this step would avoid confusion with communicating the data to the public. Now with the data, some of the key findings. So instead of showing you this very busy table, what I'd like you to focus on is this summary of the daily PM 2.5 concentrations across the different sites. So here you can see at the bottom part here, the lowest value we have observed so far since the monitoring started was in the open space in Rizal Park. So the concentration is around 13.3 micrograms per cubic meter. And here in the Freedom Triangle near the City Hall, it's around 20.4. If you're wondering what the colors meant in this particular diagram, the green one is compliant with the WHO 2021 air quality guideline values, which is 15. If it's yellow, it's compliant with the 2005 version of the WHO air quality guideline values. So it's the same, it's the same observation in the Freedom Triangle, in the place where we are collocating with the reference instrument, and in the indoor and outdoor environment of a hospital. Now we see these orange values, and these are not compliant with WHO air quality guideline values, although they are still compliant with the local national ambient air quality guideline values. You may ask why, what's happening in these areas. This port area and the Aurora monitoring sites are the heavy roadsides. So while the Freedom Triangle is also a roadside, the volume of vehicles in the Aurora and port area is really much higher, with the port area plied with heavy duty trucks, because there's a lot of course, since this is a port area, there's a lot of vehicles that ply in that area to transport goods, so for freight. So that's one of the key observations that we've had, that it's really essential that we monitor different kinds of locations across the city. Key observations we have seen is that the highest period averages were observed in January and December, and peaks are observed from 6 to around 8 a.m. in the morning. So of course, this is also related with temperature changes with inversion, and at the same time with the activities of vehicles, the peak activity of vehicles in the monitoring sites. Before, when we only had 3 monitoring sites, we only had measurement in the roadside in the Freedom Triangle. That's why it had the highest concentrations in comparison to the open space park. It was important to note that because of the monitoring, which we started in January 2020, we were able to track changes in the concentration during the strict lockdown in the city. So it's called the ECQ. And it was during this time that we indeed have observed a drop. However, it's important to note that although there was an observed decrease in concentration, you would only expect that very significant increase in concentration if it is a roadside or if it is an area with a drastic change in activity. So for example, in the Freedom Triangle, there was a reduction of 54% during the lockdown compared to pre-lockdown. However, for other areas such as in the open green park and in the school zone, the reductions were only 25% and 15%. And right after the strict lockdown, it also started to increase again. We were also correlating, we tried to correlate the average congestion in Manila roads and the concentration of PM 2.5 in the Freedom Triangle roadside Although it was distinct in this area, you will see it was very distinct that there was a drop. It's also still very important to note that the reduction of PM 2.5 concentration was short-lived and was only significant in areas where drastic change in human activities were observed. And of course, we also have to further study the meteorological and pollution transport factors in the explanation of the values. So that gives us an idea of what were the highlights of the monitoring, giving us an idea that we have elevated values in the roadsides. And then how is it related with the emissions inventory? So when we did the emissions inventory, again, the goal is that we list down all the sources of emissions and we identify which are the biggest contributors. Doing so will help us prioritize, because definitely when doing actions, we have to set our priorities. We have to act first on those that contribute the most. The highlights of the results has shown that, at least for the area sources, the biggest contributors are from the residential sector. However, that's not the same for PM and NMVOCs, wherein it's contributed mostly by the commercial sector. So you can see here it has higher values compared to the residential sector. If we're talking about both residential and commercial, most of the emissions were from cooking. And for methane emissions, it's mainly through waste generation. And if it's non-methane volatile organic compounds, it's from the use of solvents. The Philippines was also unique in the context, well, of course, similar to other Asian countries, elevated projects with a lot of construction and roadworks. This also contributes to PM10 generation. And in the case of Manila, we estimated around 20% contribution because of construction works. What about for the commercial establishments? What can be observed is that we have the food establishments with higher contributions for most of the pollutants, both criteria air pollutants, SLCPs, and GHGs. And this can be addressed with the use of cleaner cook stoves and cleaner fuels. However, if we're talking about NMVOCs, it's elevated mostly from the category of offices, so mostly on printing, and also with the other assorted categories, which include car wash, hauling, electrical services. And we recommended that these can be addressed by changes in the use of product quality, using products that have less NMVOCs. Now, what about for mobile sources? Well, for all districts, more than 95% of emissions are carbon dioxide emissions. The rest of the mobile emissions are mostly nitrogen oxides and carbon monoxide. If you look here in this plot, this is the different districts in the city, and it's highest in Sampaloc. So that's the name of the district. And it was quite understandable, because if you see here the road network, it is in Sampaloc where we have the highest number of roads, at least for the data that we have, and it emits the highest amounts of air and climate pollutants. Another important information here upon discussion with the local stakeholders, the local government partners, is that, so here on the left side, this is the port area. So this is where we mentioned that we have elevated values of PM 2.5 as based from our monitoring. Now, Sampaloc is actually a thoroughfare wherein some trucks, so from flying here, it's an alternate route that they take. So they pass through Sampaloc. So this can also explain why, aside from it has a lot of roads, it's actually also this is also where a lot of heavy-duty trucks pass by. So how do we know that indeed it's just heavy-duty trucks? We quantified the VKT, or the vehicle kilometer traveled by each kind of vehicle for the specified road segments. And as you can see here, the biggest contributions for a lot of the pollutants, so the brown one, are the trucks. So for the blue one, that's the personal cars. So PC is the passenger cars as well. And again, in terms of magnitude of contribution, we have the highest for trucks. So in terms of magnitude, it still has the highest compared to the rest. So what does this say? When we combine all of these sources, it shows us that mobile sources dominate the emission share in the city. Therefore, if we prioritize emissions from the transport sector, then we can significantly decrease the emissions for the whole city. You might see that, again, for methane and NMVOCs, it mostly is contributed by area sources, but for most of the pollutants, it's mobile. You see this orange here, these are from the point sources, the stationary sources, and they contribute majority of the sulfur dioxide emissions. Here in the right image, what you are just seeing here is that the highest contribution for point sources can be seen in the district where the point sources are located. So that's in San Nicolas. This is why it has bigger share from point sources. That's why it's also important to spatially map the sources. So now that we get an idea of the baseline air quality monitoring and also of the sources of emissions, those information were used to develop the Clean Air Action Plan of the city. So from data to action. What is the approach? The knowledge base that we have built, we use that to create the solutions. How do we do that? Again, we understand the baseline air quality and we relate that with targets. We look at the priority sources of emissions. We look at priority districts for exposure reduction. And all of that we use to form solutions. So we want to inform targeting of pollution control measures. It's also included how do we monitor the implementation. And of course, the solutions are also based on existing frameworks. So for example, the guidance framework I mentioned a while ago, UNEP's 25 clean air measures, and other different measures that are relevant in the local context. So this is actually the summary of all the pollution control measures for the city of Manila. They are segregated based on the type of source and itemized on how it can be done. I wouldn't go into each detail of each source, of each measure, because there's still an important question that has to be addressed. How do we know which one to prioritize? How do we know which of these measures are the most effective for the context of the city? So to answer that, we performed LEAP IBC modeling to know which actions to prioritize. So we quantified the benefits of the CAAP measures. So the team, we used LEAP IBC. So LEAP is Long Range Energy Alternatives Planning, and IBC is an Integrated Benefits Calculator. LEAP is a software, and we use it to quantify, it's a quantitative approach to model energy systems, pollutant emissions from energy and non-energy sources in different time frames, usually long-term. That's why it's called long range as well. So in the case of this study, it's from 2020 to 2030. So it uses historical data to project the current, and it uses the policies and measures to model what's going to be the emissions in the future. So the LEAP is combined with IBC, which calculates the impacts to human health in terms of premature death and agricultural production, as well as contribution to average global temperature increase. In the context of Manila, since it's a small city, the study was limited to impacts to human health because the agricultural production was not applicable and the contribution to global temperature was deemed to be negligible. So therefore, it is a tool to develop mitigation action plans. And here were the scenarios that were used in the model. In relation to transport, it has been identified that what if, one of the first scenario is what if all vehicles comply with Euro 4 fuel and vehicle standards, so 100% by 2030. Another is the conversion to public transport and non-motorized mode by 20%. So from passenger cars and motorcycles, they all 20% of that shift to non-motorized transport and public transport. Another one is the conversion to electric vehicles by 21%. By the year 2030, the target is that 21% of the existing passenger cars, motorcycles, buses, minibuses, jeepneys, and three-wheelers are shifting to electric vehicles. You may ask, what's the basis of the numbers? So we ensured that the numbers we're putting in the model are aligned with national targets, roadmaps, and plans. So in this case, we look at the proposed electric vehicle roadmap of the Philippines. We look at what's realistic in terms of government shift capacity. And if you also look here, in terms of measures related to energy conservation and efficiency, we base that to the Philippine Energy Efficiency and Conservation Roadmap, which already specifies targets by 2030. So 1.2, 1.3, and 1.3% reduction for residential, commercial, and industrial sectors. Now, for the fugitive emissions, for dust control, we envision 50% reduction if there is an application of dust control strategies. So we always explain this to stakeholders that we're not going to stop the construction, but what we're just going to focus on is the control of the dust during the construction. And also the use of low VOC products and approaches to control NMVOC, and more managed approach in controlling CH4 from landfills. So what were the outcomes? So for pollutants related to particulate matter such as PM10, PM2.5, OC, and BC, and nitrogen oxides, the measure that had the biggest impact would be the compliance with Euro 4 standards. Respectively, the percent emission reduction is from 75%, 84%, and 50% reduction, respectively, with these pollutants. For the energy efficiency, scenarios can lead to 14.3% reduction of emissions, and then for methane, landfill management had the highest emissions reduction. So from this alone, because of the model, we're able to identify which to prioritize among the measures in the CAAP. So what's the impact? In terms of PM2.5 concentration, the projection based on existing data in 2019 is that by 2030, if we don't do anything, so under the BAU, the projected population-weighted annual PM2.5 is 38. So from 2019, it's 33. The projection is 33. And by 2030, it's 38. But if we apply all the measures run in the model, instead of 38, it would be 36. So there is a 2 microgram per cubic meter reduction in PM2.5. And in terms of health and economic benefits, because of these decrease in the concentration, we are avoiding 146,000 premature deaths by 2030. This is definitely an improvement from the values in 2019, because we are modeling that what will happen if we apply the measures. And if we look at the avoided premature deaths alone in 2030, that's 3,000. But if we look at the avoided deaths from 2020 to 2030, that totals to 16,000 avoided premature deaths. So what are the associated economic benefits? Of course, when we avoid the health impact, we avoid healthcare costs. And this is equivalent to around $6 billion US dollars in 2030 alone. And again, since we are expecting to see the decrease from 2020 to 2030, the total accumulated benefit would reach up to 32 billion US dollars. So here, as you can see in the plot, most of the avoided premature cases are estimated to be reductions in acute lower respiratory infections. So in this regard, what are the way forward? So what has happened since then that we have collected all the data and also modeled what would be the impacts? So the current and future steps is that we continue to operationalize the Manila City Clean Air Action Plan. by implementing the priority measures. So we also want here to focus on the formation of a transport core group and the formation of a city transport office, since our priority measures are focused on transport. We wanted to continue engaging the community as seen here in the photos, because all solutions must be through a transdisciplinary approach wherein there's a co-innovation process. We work together with the stakeholders, and we also make sure that we dialogue, we do discussions with the national government. So in this case, it's the DNR, EMB, and CR, and other surrounding Metro Manila cities. We will also ensure to continue capacity building trainings for the city of Manila and improve air quality communication so that stakeholders, the public, can support the implementation of the CAAP measures further. So with that, these were actually the summary of the policy recommendations that we have because of all the analysis that were done. And we're working on the actual implementation of all these steps with the rollout of these steps. And what are the key takeaways and lessons learned? So this is my final slide. So definitely data is key. Comprehensive data collection and analysis is essential in justifying the need for urgent action. You want to justify the need because this is how you get the support of the government, the public, private sector. And when you have data, it will help you identify your priority measures. It will help you streamline what to do first, since as we all know, the resources are always limited. There's always problems with budget. That's why we have to be more efficient in knowing what steps to take first. And when you have data, it guides decision making with higher level of certainty. It's also very important that aside from data, we enrich partnerships. When there are partnerships, there is progress, because the partnerships and collaborations lead to more efficient use of resources. I wasn't able to elaborate further the many partners that we have also from the academia, but at least with the presentation, we hope it's also clear how private sector, NGOs, and the government can work together towards something like this. And when we have partnerships, the measures are further aligned with the goals of the stakeholders, and not to mention the goals even at the national level. So what we're also trying to do is to link further actions targeted at the national level. We incorporate it at the action at the local level. And ultimately, capacity building of partners pushes sustainability of efforts so that even after the program, partners can continue the efforts. So with that, this is actually my last slide, and I'd like to thank you all for listening. And of course, just to mention as well that there's a whole team working on this. So also in attendance is Ms. Precious Benjamin, and we also have Dang Casanova, David Ekal, Dana Babella, Erica Macapagal, Dr. Wee, and Dr. Thao, who has also participated in the study. If you have questions, I'll be very glad to answer them. Thank you very much.
Thank you very much, Elaine, for your very, technical and inspiring presentations. I think many of us have learned a lot regarding how advanced and then how active that Manila and also Clean Air Asia is. Yeah. So I think we can have the question and answers at the end of our presentation. Then we can have everyone that can give some more question and give some time for the participant as well to also give compliment as well in your presentations. Yeah. So please also stay in the end as well. See you later again. Thank you very much, Evelyn. Yeah.
Thank you.
So the next, I would like to invite Dr. Mustaq Ahmed Memon, Regional Coordinator for Chemicals, Waste and Air Quality Sub-Program, United Nations Environmental Program, Regional Office for Asia and the Pacific, to give the speech on sustainable waste management as a tool for clean air solutions. So I would like to shortly introduce Dr. Mustaq. Yeah.
Thank you.
Yes. So Dr. Mustaq has worked with UNEP for more than 16 years, and including also 11 years at UNEP's IETC for waters and sanitation and waste management, as well as having 5 years at UNEP's ROAP. So he was also working as director for rural waters, supply, and sanitation in Pakistan for 4 years. He has also served as a port engineer for 6 years. And also like at Ropes, he served as sub-program coordinator for resource efficiencies. He led UNEP's COVID-19 response on medical and humanitarian space, focusing on COVID-19 waste management. And Dr. Mushtaq served as project manager for the regional policy advocacy component of the EU-funded Switch Asia program to promote sustainable consumption and production, as well as uptake of SDG 12 in Asia. He also implements GEO's 4 SDGs, Go for SDG in the regions, and led the low carbon lifestyle challenge startups. Then he's also like got doctorates in environmental and resource economics from Hiroshima University in Japan, and got master from University of Bradford in UK, and got diploma in transport and undergrad in civil engineering from Pakistan, having also schooling at college Petros in Pakistan, and published many papers in international journals and deliver many training programs. So welcome Dr. Mushtaq to presentations. The floor is yours.
Thank you, Professor Thakur. So let me share my screen, please. Okay, so I hope all can see my screen. Okay, so let's talk about air pollution from open burning, but I will be more talking about the solution side. As we all know, the data like from the open burning is black carbon, the PM 2.5, and there's lots of SOx, NOx, and so many like other local air pollutants and so on. So I will not be talking about the data as there, but I'm more talking about the source of the problem and also the solution. So that's today I'm trying to bring that one. Now, when we talk about why it is happening, so if we look on Asia Pacific, there's an economic growth and consumption is huge, pertaining to the increase in the middle income, affordability, and also to our lifestyles. So even when we had a COVID lockdowns, we saw the huge consumption. And even the orders, food orders at home or the online shopping and everything increased. So we can see that this consumption brings a lot of waste. And that is where one of the key problem is there. And also this consumption is taking away a lot of natural resources because enforcement is weak and so on, and polluter principles are not working, extended producer responsibility is not up to there, and so on. So there are various challenges with that, but what we are seeing on the one hand, we are losing our natural resources rapidly because of a huge consumption, and also we are generating a lot of waste. And that's where we see the waste generation has increased rapidly in whole world, but more in Asia Pacific. You can see the figures here. And that is again also the challenges that in the developed countries, it's coming to the saturation level. But in the economies in transition, it's still increasing quite rapidly. So that's another challenge to look into that. And then within that waste, there's another challenge is that what is the like a type of waste is there basically. And again, when we see the developed countries, there's a lot of plastics, for example, or a lot of waste which can easily be recycled. But in the developing countries, most of the waste that even coming with the dust, with like a lot of street cleaning and a lot of food waste and so on, so which is mixed and not easy to recycle. So that is another major challenge we have here. And as I mentioned, that we can see that waste generation rates are related with the economic growth. However, waste management rates also related with the economic growth. So most of the developed countries like Korea, Japan, and so on, Singapore, they have quite effective, at least the waste management, even they have a high waste generation levels. So that means the biggest challenge again comes to the economies in transition, that on the one hand, even their waste generation is low, but the littering and also the management is low, and that is also resulting into the open burning and open dumping and so on. So when we talk about the waste collection rates, as I mentioned, you will see the low income countries is 39%, lower middle income, 51%. So that means there's a lot of uncollected waste. And that is resulting into the streams going to the open burning and all these things happening there. And again, if you look on the South Asia and Southeast Asia, the collection rates are not very high. Even South Asia is 44%, and as per this World Bank report, or even then Southeast Asia, 71%. And also we can see that the fees are much lower, though it's related again with the economic growth or the GDP or the affordability. But that is again the major challenge, is that because there's not the waste generation related with the polluter pay principle to charge accordingly for waste management services, this is a major challenge for the local governments and the national government in developing countries to afford the proper waste management systems, including recycling systems. So when we talk about the treatment, as you can see that there's a lot of open dumps, like a 33% is the open dumps. And if you look on our again, East Asia and so on, so this is more of the open dumps, or we call the landfills, which are unspecified. And that's where the waste is burned and so on. As you saw in my this first title photo, which is basically, you can see the situation of the landfills and so on, that open dumps, how they are burning. So we have to now see this is a source of the challenge, that open burning is happening, and open burning is creating havoc in terms of health impacts, in terms of impacts, or even on the creating water pollution, soil pollution, and so on. So when we talk about the Asia Pacific taking action to improve air quality, and here again, in addition to the household waste, we saw the agriculture waste is the biggest, because you might have heard the word slash and burn. Like if you, in Thailand, if you move to Nan province, when there is crop is cultivated, and after that, they have to come with a new crop, they have to clear the lands. Same in South Asia and many countries, and they just burn the residual agriculture biomass. And that is the biggest challenge, again, for the air pollution, as you saw even a lot of in the northern Thailand and other places, haze and so on. So this sustainable agriculture is one of the key for open burning of the biomass or agriculture there. And also, if you see the solid waste management here, waste burning, so you can see that only like a few countries, like 6 countries in the waste burning or agriculture, like 17, there are not many, they still have a very clear policies on that. And as we see that about 41% of the countries, they have the programs to promote the sustainable agriculture practices to reduce the air pollution, and including from the open burning of the solid waste and so on. But you can see that there are like 26 countries working on that, the burning of solid waste and so on. but that effective implementation is not there. And as I talked also that in addition to the household waste management, the waste agriculture biomass is 140 billion tons like over the world. And most of that is not utilized. And again, most of not utilized is open burn. So that is where the challenge is that on the one hand, we or our countries are short of energy. And on the other hand, we are burning energy source to create the air pollution. So this is where we also looking for the solution that how this energy source can be transformed either into material recycling or energy recycling or recovery through different technologies, including the combustion, gasification, pyrolysis, and so on. So to do so, to achieve that ideal environment where all our waste is going to be converted into the energy source or material source, we have to look on the different models. And as you might have heard about the Thailand's BCG model, biocircular and green economy model. So that is basically is about in the global terms is a circular economy model, where you have to see what is the impact of the natural resources in the economy and what is the outcome in terms of emissions, waste, and so on out of the economy. And in the linear economy, as we saw that we take, make, and dispose, here we have tried to recreate the resources by utilizing waste. As I mentioned, that either material resources, so we can complement our natural resources or the energy sources and so on. In that way, on the one hand, we reduce the pressure on the natural resources, and on the other hand, we can create the renewable energy and reduce the waste and emissions out of our economic activities. So this circular economy model is the key to focus reducing or controlling the open burning of waste and agriculture biomass. For that reason, UNEP coined this idea of decoupling in 2010, that our economic activities should be decoupled from the negative environmental impacts. So suppose that road we travel, like our mobility or transport, it should not be directly proportional to the emissions we emit from the transport. So if we move to the public transport, we reduce that. And if we make the public transport running on the renewable energy, we further reduce that. And we get the renewable energy from the waste, that we further reduce that. So this decoupling is very important to look into that, how you make the efficient model for the BCG or circular economy. And for that reasons, in the last decade, we saw the waste management for the municipalities meant to collect and dump outside. But then we saw a lot of challenges coming as open burning and everything. So then this idea came that waste is not a waste, it's a resource. And we have to treat it as a resource management. So it can be source segregated, it can go for the recycling and recovery. That's how this whole idea is coming, to stop the open burning and rather recover the energy and material value from waste. And that's why this recycling competition has started, that the countries who are reaching to the numbers, how much of their waste they can recycle. And in Europe is stand out. And then also Asia is picking up, but still we have in the range of 15 to 20% only. And that's why the UNEP's focus is how we can create the circular economy models based on in the local context, depending on the type of waste is being generated, how it is generated, and what are the possible ways to recycle or recover, and what are the market opportunities to connect that to the market so we have a demand and supply and so on. And for that reason, if you look on the history of the Asia, that we started our industrial era in 1970s, where we started with the pollution dilution. Then we came with the end of pipe solutions to avoid air pollution getting into the skies and so on. Then we further improve our systems as a clean production. So even we reduce the less negative environmental impacts. And then we move to the eco industry and green industry, including in the agriculture sector and so on. And we created industrial symbiosis or eco towns where waste of one industry can be the source for other industry and so on. And then we further enhance sustainable consumption and production. So we consume responsibly, we produce responsibly, and now we are in the era of circular economy or BCG. So this is a huge learning, huge knowledge already there, which is very useful for us. And that's where we are looking on the policy side. We are looking on the technology side, standards. We are looking on the regulations, incentives, as well as the private sector engagement through sustainability reporting, through environmental social governance investments, and also access to the finance for circular economy. And that's where all the sectors, whether it be the government in its role as a regulatory frameworks, policies, institutional setup, tariff designing, subsidies and guarantees, the businesses, whether upstream businesses who are the producing the products, or the downstream businesses who are recycling and collecting and providing the services, altogether they have their financial share. Technical innovation, the manager role for efficiency, local knowledge, and with the backward and forward linkages across the full value chain. And the most important comes us as a community. What is our willingness to pay as per polluter per principle, our awareness and will for environmental friendly lifestyles. So UNEP came in 2006 and 2007 with this integrated waste management idea. And we started building on various sectors, as I say, including waste agriculture, biomass, including household waste, e-waste, plastics, you name it. And that's where we have a huge range of the pilot projects, the knowledge, the guidelines, and everything. And the most important learning came that recycling is the last resort, because in recycling, you lose the embedded values. You waste, like there are wasted capacities, because if you produce a, let's say, plastic bottle, and even if you recycle to 100% efficiency, you lose all the values of producing that bottle, the energy behind that, the water behind that, the labor behind that, transport behind that, and so on. So that's why the focus is the longevity of the products, reuse of the products, and finally the recycling, and finally the recovery. So UNEP has a lot of toolkits and training that's we have in all the aspects, including on the waste agriculture biomass. And then, as I mentioned, that we have started the initiatives. One is the circular economy in Asia and Pacific, CEP. Other is the circular cities. And third, and which is more important for you, is the circularity and youth, that how youth can be involved. Because youth, on the one hand, they are the major consumers, and they are now like a digital technology leaders. And then on the other hand, youth are coming with a lot of new innovative ideas, startups. So they are producing the environmental goods and services, including the shared economy models and so on. So this is where we are working with the youth like you to come with the circularity model to reduce the negative environmental impact while we grow economic, social growth we achieved the SDGs, we achieved the UN decade for the ecosystem restoration, we achieved the climate change goals or carbon neutrality and so on. So thank you very much.
Thank you very much, Dr. Manon, for the presentations. Yeah, so we have seen also like no more regarding like how circular economy could help sustainable development as well as also contribute to clean air solution as well. Yeah, so I would like to then invite our next speakers, Associate Professors Wongpan Limpaseni, Directors of Center for Clean Air Solution or CCAS. Yeah, to give the presentation, I will briefly introduce him regarding his background and then also previous research. Professor Wongpan obtained his Bachelor of Engineering degree in Civil Engineering from University of Western Australia, as well as graduate degree in Public Health Engineering from University of London and Imperial College of London. Then also he's an air pollution expert with more than 40 years of experiences. His work including like air quality monitoring, air quality standard settings, development of air pollution inventories, air dispersion modeling studies, ozone precursors, as well as also like the work presented today is about the development of strategic plan for controlling PM 2.5 in Bangkok. So he was head of the Department of Civil Environmental Engineering and Vice Dean in Research in Faculty of Engineering, Chulalongkorn University, as well as also Vice Directors in Education Divisions, Institute of Metropolitan Development, Navamintara Universities. And now he's also the Director of Centers for Clean Air Solution. So I would like to invite Dr. Wongpan to present about the clean air solution in Thailand. Welcome, Professor Wongpan.
Good afternoon to all. Thanks to Dr. Takan for inviting me to introduce Center for Clean Air Solutions. Does the PowerPoint come up all right?
Not yet.
Not yet. Can you share it for me?
Wait for a minute. Wait for a minute. We have some technical problems. Okay, I think it's coming. It's almost there. Not yet. Okay, yes. So the slide is there.
Flickering.
For a minute, So everyone, in case that you have any comment and suggestion or questions, please also feel free to leave it in the chat box. Later on, we will also try to answer and then also give the response during the Q&A sections. Wait for a minute.
Okay.
And then please also register with the link that will be sent shortly. In case that we will also send the presentation slide of our presenters via email that you give in the chat box. ค่ะอาจารย์
Okay, thank you very much. Next, I will give brief introduction to the Center for Clean Air Solutions. There are already 3 items. The first one is the air quality situation and trend in Thailand. The second topic is introduction to our Center for Clean Air Solutions. And item 3 is the work progress done so far during our first year of setting up the center. Next. For the air pollution, the main problem now in Thailand is the PM2.5 with the emerging problem in ozone and some other pollutants. But today I will emphasize on PM2.5. This figure show the annual average of PM2.5 in Thailand for each of the region in Thailand. The two top most line in green, in pale green, is for Saraburi, which is just one province. The dark green is the northeastern region. The pink one is the northern region. Bangkok itself is the yellow line. You can see that for the northern region and the rest of Thailand, the air quality has improved for the last few years and coming close to our air quality standard of 25 microgram per cubic meter. But this is still much above the WHO air quality guideline of 5 microgram per cubic meter. Next. Let's look at more detail of PM2.5 in Bangkok. The top line, the green, is the maximum PM2.5 for the last 10 years. You can see that the level is decreasing from more than 100 microgram per cubic meter down to 85, but this is still much above our standard of 50 microgram per cubic meter for the 24-hour average. And for the blue line is our annual average, which also decreasing from the maximum of 35 microgram per cubic meter now to lower than our standard of 25 microgram per cubic meter. But of course, this is still much above WHO standard of 5 microgram per cubic meter. So we have a lot of work to do to improve our air quality, especially in terms of PM2.5. Next. Next, please. So we back a bit. So the Center for Clean Air Solutions, to page 5, yes, thank you, was set up by the Thai Health Promotion Foundation to be a center for academia in the development of knowledge as a foundation for driving, communicate, provide direction, and supporting policy and measures for prevention and mitigation of air pollution with participation from stakeholders. Next. Our 4 objectives are: one is to set up the Clean Air Solutions Center, which will have joint effort by academia to work together to find the solutions. The second objective, from the knowledge that we have, we try to synthesize the knowledge on PM2.5 to support decision making on PM2.5 solutions. Number 3 is to disseminate information on prevention and control of PM2.5 to the society. And last one but not least is to build up a partnership with our stakeholders to move forward proposal on policy and measures for PM2.5 mitigation. Next. Our principle on air quality management have 3 steps. The first one is to control of emission sources. And the principle behind that is the polluter pays for control of emission sources. Then we have management of transportation and dispersion of air pollutants. This must be done by the state. Then we have to control exposure by the population to ensure clean air for all. Next. Our output emphasize on the knowledge series. This is to synthesize of information to produce knowledge series for the society. The first group of knowledge series is the control of emission sources. Emphasize on sources from transportation, from the industry, on the open burning, which include forest burning, agricultural burning. Then we do the management of air pollution. Emphasis on control by area. This means we have to understand the emission by the emission inventory, as well as the emission impact on the area that we come about by the receptor model. Then we do the laws and regulations and management of air pollution, as well as to do the modeling of air pollution to give guidelines for air quality management, as well as prediction. The last column is on reduced exposure by the public by provide awareness to the public how they cope with air pollution when there is a crisis on air pollution, how they use the mask, how they set up clean room, what is the best way to act in the event of air pollution. And the second one is on public relations and public participation. This is to communicate with the public on providing information, as well as gather feedback from the public. This lie on the basis of general knowledge to the public, give them information on effects on health, as well as impact on economy. Next. We also developed air quality management tools. The first one is benchmark for evaluation of health and economic impact. The second one is to develop emission inventory. These 2 tools, the first one, benchmark, is actually US EPA model, but has been modified for Bangkok, for Thailand. Thailand set up with the data from Thailand, and it will be an open platform for all to use. the emission inventory is also an open platform where we aim that it can be used by all in Thailand, and especially it will be used for area-based management for all the 27 provinces of Thailand. Next. This is an example from the BenMap program by Dr. Thao, which we have determined the benefit to health and economic of improved air quality PM2.5 to WHO to 2005 guideline of 10 microgram per cubic meter. That we will have the air benefit shown in the map of Thailand in color, grading according to the amount of air benefit in microgram per cubic meter. The dark green, of course, is the south of Thailand, which is a good air quality. So there is no need much for improvement. But you can see that for the northern Thailand, the northeast Thailand, as well as the central, we can reduce air pollution by a large number. And the figure is that the benefit will be up to 16 microgram per cubic meter for annual PM2.5 reduction, which can translate the host just muted me.
Sorry,
and this can be translated to 110,000 avoided premature deaths, and translated to economic benefit of $125 billion. However, if we aim for the WHO guideline year 2021 of 5 microgram per millimeter, we can reach the air benefit up to 21 microgram per cubic meter, as well as health benefit of avoiding 120,000 premature deaths, and reap the economic benefit of $194 billion. Next. For all those information, the tools we have, we aim to put it into use for the local community, local government. So the first one that we have applied the information and the tools is for Chiang Mai. We have the workshop on PM2.5 control strategy planning for Chiang Mai in March, just early this year. The brief agenda is to cover the air pollution situation and trend in northern Thailand. We give a talk on guidelines for developing air quality action plan. Then we provide the audience with the health database and build a program for evaluation of health impact with exercise, followed by emission inventory with exercise. Then the participants gather together to review the air quality action plan for Chiang Mai, which is in existence, as well as to have group discussion on alternative measures for air quality control in Chiang Mai. Next. The expected outcome from the workshop is to first is to understand air quality situation and trends in Chiang Mai. Chiang Mai, by the way, is the second largest city of Thailand in the north of Thailand. Then we want them to be able to evaluate health benefit from air quality improvement or realize the loss from air pollution. The third item is to be able to evaluate economic benefit from air quality improvement. The fourth one is to be able to rank or prioritize emission sources by sectors. And number 5 is to propose on air quality control measures. Next. So this is the figure from our workshop. Next. Just to give a glimpse into what information we give to the audience. The first slide on the top left is the air quality in Chiang Mai for the non-haze and the haze period. The second one on the top right, you can see that the PM2.5 concentration is very per kilometer, but it's very concentrated during the haze period. The rest of the year, without burning, the air quality was much improved. This is due to the sources as shown in the lower left figure, that the emission sources are from biomass burning. This is the figure for Thailand as the neighboring country, including Myanmar, Laos, Cambodia. They contribute to the air pollution in Thailand. But for Thailand, the figure on the lower right show that the hotspot from the 9 provinces in the north of Thailand. So this hotspot from the biomass burning is from the forest area as well as the agricultural areas. Next. This is a map of Chiang Mai. The different color show the different land use. Sorry, in Thai, but the different land use is the forest area or agricultural area. On the right column is the number of average for 3 years, and the far right is the target of this year, that we want to have the hotspot reduced from 15,000 hotspot to 12,000 hotspot. For the burn scar area, reduced from 1 million rai, this is in Thai, down to about 800,000 rai. With the PM2.5 above the standard, reduced from 77 days down to 62 days, and the maximum PM2.5 from 256 microgram per kilometer down to 204 microgram per kilometer, with the hospital admission of COPD patient down from 8,000 people down to 6,400 people. Next. So this is the output of the workshop, where the participants have exercised and come up with difficulties from the tools that we gave them using the BenMap program with the Thailand setup. We can see that for the if they improve the air quality to the Thai standard of 25 microgram per kilometer, the PM reduction is 13.77 microgram per kilometer, having avoided death per year of 356, and have the economic benefit of 13.9 billion baht. If we aim for the WHO 2005, please correct that to 2005 standard of 10 microgram per kilometer, we will have the PM reduction of 23.7 microgram per kilometer with the avoided death per year of 609 people and an economic benefit of 23.8 billion baht. And if we look further and try to improve the air quality in Chiang Mai to the WHO 2021 standard of 5 microgram per kilometer, we can make reduction in PM2.5 up to 28.55 microgram per kilometer, resulting in avoided death per year of 730 deaths per year and resulting in economic benefit of 28.5 microgram per kilometer. This is based on the value statistical life of Thailand at 39 billion baht, based on $1 equal to 31 Thai baht. Next. The participants, after they did the exercise on BenMap, they also gone to do the emission inventory of Chiang Mai, and on the left side is the result of their efforts. So they can come up with the sources of PM2.5, showing that the forest fire contribute 48% of PM2.5. Next is the transportation, and then all the rest. For the transportation sector, the truck, the pickup, and the motorcycle are the main polluters. So they can prioritize the emission sources they want to control. And this is just an example of the tools we give to the local government, local people, local NGOs, so they can develop their own action plan to manage air pollution, especially for PM2.5. Next. Another exercise that we did to the local people is the project on low emission zone in Pathumwan district. This is the district in the central business of Bangkok, consisting of the voluntary emission control in CBD of Bangkok. And firstly, we set up the air quality sensor network to measure air quality before the project and during the project to see if we make any improvement. The second item of the proposal is to raise awareness among participated 21 business identity, the government, the NGO. And the third item is to campaign on emission testing and repair to reduce emissions. Next. Yes. This is the map of the area of the Rama Road from Pathumwan intersection at MBK Center to Rat Pasong intersection, which is a Center World shopping center. This is a very highly dense area of commercial identities. So we set up 4 sensors on Rama Road, and the result can be shown real time that the public can be seen, and the stakeholder can look at this information in real time. Next. So on 20 January this year, we have a kickoff program with all the stakeholders, 31 of them, join force together, that we will move forward to reduce emission on vehicles entering the area on a voluntary basis, providing them with the education, providing this information, as well as doing the emission testing and repair of vehicle. Next. So earlier this month, we have a campaign on emission testing and repair hosted by MBK Center, where we set up a center for testing and repair of this vehicle, motorcycles, give them testing of emission, as well as to repair on the vehicles if they exceed the standard. And there were 668 vehicles joined the event, and of course this is just an example what can be done by the local community, and hopefully this will propagate for the whole community of Bangkok in a larger scale. So my talk, of course, is that our Center for Clean Air Solutions has developed the knowledge series, which is to disseminate to the public, provide tools which can be used by the local governments, as well as doing the develop action plan by the local government, as doing the joint effort and by the local communities to reduce emission. Thank you very much.
Professor Wongpan for a very nice presentation on Centers for Clean Air Solutions. I think we have now 3 presentations and quite, it's like online seminar, and so that everyone could have some kind of like short break and come back again. Yeah, so I would like to have a 10-minute break. Then we'll back together in the seminar again. Yeah, so see you very soon. I think I see some question left in the chat box. Please also feel free to leave questions or issues that later on we will discuss during the panel section. I think that I have some like very interesting issue already, because we know that clean air is also important thing for life of everyone. So I would like everyone to just think about what would be relevant to you, and then how can we contribute and help together in this one. Yeah. So now it will be my presentation. As Professor Dr. Takan Prahat for Faculty of Engineering, Mahidol Universities. So in fact, I'm not air pollution expert, but I'm expert in life cycle assessments, right? Which also considering like environmental impacts from product and service throughout life cycles. And air pollution is one of the important environmental problems and environmental impact that being captured in also life cycle assessment. So I will also demonstrate how life cycle based assessment and life cycle based tools could be applied for helping air pollution problems, and by using a case study in Bangkok. And then if you have any problem or any concern, please also feel free to leave in chat box or contact me with email anytime. Yeah. So today I will give you the presentation about PM2.5 and health impact reduction options for road transport in Bangkok metropolitan regions, Thailand. Yeah, so the outline of presentation, actually you have also like listened to many presentations regarding the health impact from air pollution. So I would like to give you some short address more, and afterward will be about the health impacts and cause of PM2.5 formation from road transport in Bangkok metropolitan regions, or shortly named like BMR. And afterward about the options and also the policy implementation measures in BMR. So this is going to be the presentation for my part today. Then the picture show you about the global statistics, like demonstrating health impact from air pollution. In fact, air pollution is the important risk factors causing the death from non-accidental death, like the fourth important factors. It's also in 2019 it caused around like around 7 million deaths around the world. Then specifically for PM2.5, it's caused 4.14 million deaths, and it account for like 118 million disability adjusted life year based on the state of global air in 2020. So this also shows that it's important cause of death. So if we would like to like stay healthier and then also stay longer, we need to really take care of like air qualities. And in fact, many countries around the world also have many policy and action to improve air pollution. And in many regions, it also shows that it also have better air quality, but the health impact is worse. Because recently in global air, state of global air also presented that although you may have some better air quality, but because we have different population. For example, we have like higher risk people with older group of people. We are going to aging societies. It means that our population are more at risk of the pollutants. So that's why we have to work more seriously toward the clean air. And this one showed about Thailand statistics that in Thailand in 2019, based on the Health Effect Institute data, nearly 41,000 deaths due to the air pollution. And for Thailand, air pollution is the mortality risk factors ranked number 7. And you look at the figures here that the average annual PM2.5 from 2011 to 2020. So if we see the annual average data, so we have 3 standard lines here. The first is like PM2.5 annual standard for Thailand is 25 microgram per cubic meters, which are on average for the whole countries. We are able to manage to be under the regulation in some years. Yeah, but in other years, we also like cannot really follow the standard. But if you look at the WHO standard, the old one or the new one, currently we cannot really reach the standard. So we have to really work hard in order to be there, like have the healthiest condition in our countries. And this is not the only condition in Thailand. In fact, more than 90% of people around the world also live under the air quality higher than the WHO guideline. Yeah, so this one is also one of the concern that we have to try to join hand in hand to solve this problem together. So this is about health impact from air pollutions. Then what could be the source of the air pollution? It could have like the outdoor air pollution affect urban and rural areas. It could be caused by industry, energy supply, transport, waste management, household energy, agricultural practice, and also dust. Yeah, so you also see that also waste management and circular economy could also reduce air pollution by Dr. Mewans, and also transportation could be very important role in Manila, as also the case in Bangkok, which I will show you very soon. So for the source of PM2.5 emissions in BMRs, so these pictures show you the source of the PM2.5 emission, but exclude the biomass burning for land preparation in agriculture. So road transport consists of 54% in the BMR regions, and followed by industry 22%, household 11%. And in the road transport, trucks and pickups are also majorities, and followed by bus and passenger car and motorcycles. So based on this inventory information, it's important that we have to capture the hotspot in order to reduce the impact. So that's why our studies also focus on the road transportations in this also presentation and the research. So we have conducted the research on health impact and cause of PM2.5 formation from road transport in Bangkok metropolitan regions. So this is also based on the master thesis of our university student, Mr. Sinchunon Chawanwes, in collaboration with researchers and also like supervisors from different universities. So we try to solve the problem by considering the existing plans from Thailand. So we have like the plan, the roadmap. We have national roadmap to solve particulate matter pollutions from Thai government that have approved, and the pollution control department is the main host regarding this action plan, and is a part of the national agenda in order to tackle with the PM2.5 emissions and also the problems. So the roadmap provide policy frameworks having like around 125 operating guidelines. And we think this is the problem. If you have more than 100 guidelines, which one to do first? So it is important to quantify the benefit of this guideline, and then to identify and rank that which guideline should be carried out first, and to have which one could be the most effective in terms of the health impact and cost reductions in the specific regions. So the objective is this studies to estimate emission inventories of primary PM2.5 as well as secondary PM2.5 precursors like NOx, sulfur dioxide, ammonia from road transport in Bangkok metropolitan regions for scenarios based on this guideline. So we have to tackle with the guideline and came up scenarios, and then have inventories development. And afterward, in order to assess the health impact and cost of this inventory, we also adapt and determine Thai specially differentiated characterization factors for 6 provinces in BMR. So previously in LCA, we used characterization factors to assess health impacts. And previous study, we used one factor fit all, that we have these factors and can be used for the whole world. But in fact, the emission from different areas, different provinces have different effects. So in this study, we also have the provincial specific factors or city specific factor in order to determine health impact and cost, which I will show you later in detail. That's how we do it and what would be the result of our studies. And also to quantify human health impact reduction and economic benefit due to transportation related PM2.5 emissions of scenarios based on the guideline. So the main highlight that we got from this research, the first is like cars or vehicles driven in Bangkok cause more health damage than driven in other BMR cities, due to the fact that the Bangkok have like higher populations, and also the other factor that affecting the air pollution that causing more health impact in this province. Then the second highlight is about retrofit vehicles with diesel particulate filters and also 10 ppm sulfur fuels or like the low sulfur fuel led to the highest benefit as of 14 billion Thai baht in the economic benefits. Then also upgrade vehicle emission standard led to larger benefit in 2029 than 2024. With some policy, we need to wait to get the effects. So in this case, so sometimes we have to ensure that our assessment should also have long time enough in order to capture the potential benefit of the policies. And another surprise that we got from this study is that electric vehicle led to little health benefit over 10 years after implementations. But bear in mind that we have considered only electric vehicle based on the chain of passenger cars and some specific type of cars, not all the type of electric vehicle included in this study. But still, based on the current plan, that this is also the focus of the change that occur in our country as well. So it's also show that perhaps the current policy you have to reconsider as well. That which one might be the best one and how can we push forward for the more effective policy. And of course that if we consider health impact of the life cycle emissions, including the whole supply chain from fuel production and also fuel consumption, it is obvious that the health impact are around like 1 to 6 times higher when the emission include also like life cycle emission from the supply chain. So these are the main highlights from these studies. So let's see the scope of our works. The first one is about the functional unit that these studies consider the total road transport services, including passenger transport, as well as also the food transport services in BMR in 1 year at the beginnings, and then after we have projection to be in the future years. Then scope of the study area includes 6 provinces in BMR, and the consider pollutants vehicle type we include passenger cars with the seat less than or equal to 7 seats, passenger car with more than 7 seats, pickups and vans, and then motorcycles, trucks, and buses. But we, of course, this is only road transport. We don't consider rail transport in this case, or else we could have like electric train. That could be also a very good and another good option as well. But still, we see that road transport is also important hotspot. So that's why we focus on road transport first. And these 6 vehicle categories consist of 98% of total vehicle registered in BMR area. And the pollutants considered in these studies include primary PM 2.5 and then secondary PM 2.5 precursor, NOx, ammonia, and sulfur dioxide. So these show you the overall figure of the research. So start with the Pollution Control Department operating guidelines. And afterward, we develop scenarios. Then after having scenario development, the next step going to be emission inventory modelings and development. So we have emission inventories of PM 2.5 from well to tanks, and then also from tank to wheels as well. So in case of the supply chain emissions, like from fuel production, we will use global correction factors to calculate estimate human health damage. And then for the emission from fuel combustions, for the primary PM 2.5, so we have used the intake fraction from Thai city-specific factors, and then effect factor also from city-specific factors to get human health damage, and afterward calculate the cost of human health damage per year. And for the emission of PM 2.5 precursors like NOx, sulfur dioxide, ammonia from fuel combustions. So for intake fraction factors, we include global factors, and for the effect that when you breathe the air, what would happen? So we use Thai specific factor in that case to estimate the health damage from fuel combustions. So this one show you about emission inventory modelings. Then we have emissions of PM 2.5, NOx, and ammonia using the method used to estimate like tier 2 methodology from IMEC-EAA Inventory Guidebook 2019, which have considers like number of vehicles, average annual distance, as well as emission factors. So these are the parameters that we have used, and we have collaboration with pollution control departments and various researchers in order to get up to date and then the most available, the best available data to be considered in these inventory developments. But for sulfur dioxide, it's directly calculated based on the sulfur dioxide content in the sulfur content in the fuels. So after we have emissions, then how can we have the impact assessment? So these figures show you the impact pathway for assessing human health effect from PM 2.5, and which is also adapted from Thank you et al., who is also one of our co-researchers. So first we have like mass of PM 2.5 or precursors emitted to the air, and afterward, everyone inhale. So we consider intake fractions that what could be the kilogram of pollutant inhaled per kilogram of pollutant emitted. And after having like this factor, we get the mass inhaled in terms of kilogram of PM2.5 inhaled. So we quantify human health damage by multiplying with effect factors. So what could be the human health damage in disability adjusted life years per kilogram of PM2.5 inhaled? So we got the human health damage, and these impact fraction and effect factors is characterization factors that we use in life cycle assessment. After we have human health impact, the next we can quantify by using the value of health impacts, Thai baht per dali, which is approximately around like 600,000 baht per dalis, which also based on as well the research. So I just give you some briefly information that what is dalis. It is like a disability adjusted life years. It is measures of the overall burden of disease, including years of life loss due to early death and years spent living with disability or with ill health. So this one could be used as one of the unit and measurement as for the health impact, not only for air pollution, but for other diseases as well. So by having this unit and this assessment, it can be applied for other emissions or other impacts that causing the health impact. Not only PM2.5 related emissions, but in this work, we focus on these PM2.5 related emissions. Regarding the highlight that I told you earlier, that Bangkok is like car driving in Bangkok cause higher health damage in other provinces. Why? This picture can show you more clearly that city-specific PM2.5 value from 6 different provinces in BMRs, including Bangkok, Nonthaburi, Pathum Thani, Samut Prakan, Samut Sakhon, and Nakhon Pathom. In Bangkok, per 1 kilogram PM2.5 emitted is much higher than like if the this one like Nonthaburi. So it's more than 10 times higher because of populations, because of meteorological data. So that different factor that affects on health impacts of specific province. And if you consider other models or other tools using the Thai average CF values, you can get another value as well. So it is important to ensure that the impact assessment model you use, it could be more accurate by using specific data. So that's why in order to ensure that our health impact assessment in Thailand are accurate. So we have please mute. Thank you very much. Yeah. So this figure also show the importance that we need to use specific data in order to quantify the impact more accurately. After we having the like how we calculate quantify the health impact, then the next is about scenario developments. So these scenarios are selected based on the pollution control department's operating guidelines. That these are the guidelines, and we got 10 cases of 10 scenarios, including like the first one we have applied like 10 ppm sulfur fuels used in BMRs. Case number 2, using electric cars make up of like 50% of new vehicle in 2024. So these are also like this scenario in this case, it just gradually increase the electric cars throughout the years in order to reach 50%, which is very high target that we aim for. Then case 3, all buses in Bangkok change to be e-buses. Then case 4, we have like apply Euro 5, Euro 6 standard according to the original plan. So in Thailand, the original plan based on the operating guideline is planned that the Euro 5 will be should have been implemented in last year, and Euro 6 should be implemented this year. But now the plan has been postponed. But this case would demonstrate that if we postpone, what would happen? What could be the loss in terms of human health damage? Then in case 5 about the diesel car ban. So all diesel passenger cars banned in Bangkok. Then case 6, all trucks banned from entering Bangkok. Then, but again, the car ban mean that it doesn't mean that the car ban and not running. They're still running, but we just not run in Bangkok, but move the car to be other provinces nearby Bangkok. So in the BMR regions. Case 7, old car ban. So the car which are older than 20 years will be banned from BMR. Case X or scenario X. So we have diesel particulate filters or DPF retrofit to all diesels below all diesel vehicles below Euro 4 or like equal to or less than a Euro 3. Then case 9 or 8.1. So we have DPF retrofit and also include 10 ppm sulfur fuel. So the low fuels include and with the DPF, which very effective one. Then afterward, the case 10 or case all, we implement all scenarios together. And of course, that the one that have some synergy together, we also consider not to have the double counting in this case. So these are 10 scenarios being studied. Then if you look at total emissions, so this is like the emission from tailpipe from the 6 types of vehicles running in BMRs. And these are the demonstration and projection to be in 2029. So SBAU means that business as usual scenarios if we do nothing. So we will have 7,234 tons of PM2.5 emissions in 2029. And you can see that they are different in terms of emission reduction. So for the car ban, they ban in Bangkok, right? Like S5 and X6. So it means that it still runs somewhere else. So in this case, the emissions are the same. And of course, that the best scenario should be as all that integrated all emission, all emission reduction. So if it's feasible, implement all would be the best. But if it is not the image in terms of emissions, the least emission could be like the having the low sulfur together with the DPF or diesel particulate filters. Then the next one, also this one, all car ban, as well as implementation of Euro 5 and 6 standard, also very effective in terms of emission reductions. Yeah, and then you see that the electric bus and car is still have some way to go that we have to try to find that how to make it more effective. Then here comes the difference. Previously, it's about the emission, right? Now, this picture shows you the health impacts. So in this one, health impact, you see that now car ban is more effective now. Why? Because if you look at the factors that when you drive the cars in some certain province and have more effects here, like in the highly populated area, you will have more affected people. And then at the end, you will also have more health impacts. So by moving the car from the highly populated areas and also some certain meteorological conditions, so you can reduce the impact as well. Then of course, the best one could be integrated all scenarios and followed by the combination of low sulfur fuels and diesel particulate filters. Then the next one could be the Euro 5 and 6 standard implementation according to the plan. And afterward will be the old car bans and followed by the others scenarios. So you can see that the e-bus and e-car still, it can reduce the impact, but it's not as significant as the others measures. Then after having the health impacts, So you can quantify the economic benefit by considering the different health impacts. And then afterward, we quantify the cost per daily or the health impact. And then we got this economic benefit of the 10 scenarios in 2024 and 2029. So you can see that is have like the best one is integrated all. Then the next one could be the same as the health impact reduction, that having low sulfur fuel together with DPF or diesel particulate filters. And afterward would be the Euro 5, Euro 6 implementations and the ban of the old cars. And then we got the ranking. Yeah, so these are the ranking from different years. But at the end, we decide that we have to see the long-term effects. So we select the 2029 scenario ranking in order to go for the first policy implementations. So these are only based on human health impact and cost analysis. We still have to have considered other factors, how can we really implement this one, and what could be the side effect of the policy. This is another issue, because of course that all policy also have cross relevance and also have some others factor that may not make that policy being the most effective one as well. It may have some side effect to society. So that's why we, after having this scenario ranking, we continuously working to develop the white papers on the PM 2.5 and health impact reduction option for road transport in Bangkok metropolitan regions. So these white papers aim to present policy options for reducing these impacts from road transport sectors. So we propose, after we have 10 scenarios, we have integrated and discussed together, having the brainstormings with various stakeholders and come up with the 7 policy options formulated based on these 10 scenarios rankings, and present also implementation measures as well as also like what are the advantages, disadvantages of different options. But in today's presentation, I will only focus on the like overall options as well as also some implementation measures, and shortly like demonstrating about the what could be the measures, constraints of each policy options, and what could be the futures or next steps that we have to deal with it. So here is the 7 policy options. First options, of course, that based on the discussion, we think that setting emission standard is also the one of the most promising option as well, because it have the effective health impact reduction and benefits, and then it can have economic benefit up to 9,000 million baht, and this also like list all the health economic benefit and health impact reduction of different options. Policy option 2, measures on removals, modification, and quality improvement of old vehicles. Yeah. And this one is developed based upon the banning the old cars. But in reality, it will have also, if we ban the old cars, we will have also like side effect on the low income public as well, which we don't intend to do that. So we have to identify that. Then what could be the measure that we can reduce the impacts and can make the old car to have higher performance. So this is also that's why we come up with these policy options. Policy option 3, installation of diesel particulate filters, and also have some various opportunities as well as also like limitation of this policy option, which I'll present later. Policy option 4, use of low sulfur fuels, which is one of the most promising one, because actually we already like industry in Thailand are ready to have these policy options, but we are also like about to be launched in the next 2 years. Then policy option 5, settings low emission zones. Like you have seen also the examples, and then the setting up case study by Professor Vongpan in the certain district in Bangkok as well. So in these policy options, we also like include a scenario based on previous study regarding the ban of the vehicles and have the economic benefit and health impact reductions. Option 6 is promotion of electric vehicles, and then option 7 is promotion of electric buses. So these are the 7 policy options that we developed based upon that previously like 10 scenarios. So the first one is about adoption of setting emission standards, which now we have a postponement of the old enforcement plan. Previously, we planned to adopt Euro 5 emission standard in 2021 and Euro 6 emission standard in this year. So now the old plan has been approved again, that we will have the enforcement of emission standard for new vehicles to be Euro 5 by 2024, together with the low sulfur fuels. We do hope that this standard could be enforced faster in order to ensure that the emission reduction and health impact could be reduced. And also these are the policy implementation measures that based on the discussion with the stakeholders. In order to really incentivize the emission standard to be implemented voluntarily before, if we cannot enforce, so one of the economic instrument could be the tax reduction. So could be reduced vehicle tax to create incentive for companies to sell Euro 5 emission standard vehicles early. Because in fact, many companies also have the Euro 5 vehicle as well, but maybe the price and then it will be still more expensive than the others, like the vehicle with lower standard. And also incentivize people or operators involved in the transportation sectors to use the Euro 5 emission standards and reduce the cost in modification of vehicles to fit emission standard that meet the required standard. And another thing that we try to also encourage that instead of having Euro 5 and afterward like Euro 6, it might be more effective to skip Euro 5 by implementing Euro 6 emission standard right away. Because in fact, the previous plan in the original plan also planned to have the Euro 5 and Euro 6 in 1 year different, because with the aim to move forward to Euro 6 at the end. But still, because of these instabilities of policy, we still have these problems. So that's why the academics and stakeholders try to acknowledge that this is very important policy and we need to move forward. Of course, that we have also we have some limitation, or we have some different or disagreement from many other stakeholders. So that's why we need to give the knowledge that this is important to put forward. And also considers opinions of our stakeholders and carefully taking proposals from our sector before setting policy. This is also important as a part to move forward to policy implementations. And then also we have also like support or encourage purchase of eco cars made and sold locally, because nowadays there are also existing eco cars that meet Euro 5 standard as well, available in Thailand. And very important that is to raise public awareness on the benefits from implementing better emission standard, which we are currently doing as well. I mean that people will know more better throughout the public awareness raisings and capacity buildings. So this is a part of emission standard, but of course, what we can do as academics sector, we just give like education and try to involve in the policy process. For option 2, measures on removals, modifications, and quality improvements of old vehicles. So if in case that we ban old car over 20 years from running in BMRs, we can have like economic benefit around like up to like 8,200 million baht, and can reduce health impacts around like 12.5 dollars. So this could be the benefit from banning old cars. But of course that banning old cars have a lot of effects or impacts on like the majorities as well. So that's why we have to try to find that the car could be old, but the old car should be maintenance and have better qualities. So this is why we modify the policy to be like measurement of removal, modification, and quality improvements. But of course, as a part of the application of this policy, first is like so important that we should have like new vehicle excise duty cuts So this could be one of the options. But of course, that not just only propose the new vehicle excise cut, but we have to ensure that when you buy a new car, the old car have to be gone from the road as well. So that have to be like some kind of mechanism to ensure that you don't add more car in the street, but you would like to shift the older car to be like the newer ones. Then encourage people to buy new car in conjunction with the reducing number of old car. This one, so by having the connection together with the tax cut. And also, like further studies should be made, but regarding the benefit from tax cuts and also investment value as well. So this is also one of our concern that, in my opinions, it's important to have comprehensive assessment before having policies. But sometimes we see that many policies have been like proposed, but without the assessment, comprehensive assessment, and that also have the problem in terms of implementations. So this one also increasing tax and fee for the renewals of the old vehicle registration over than 23 years old. Because of the old cars still have very low taxations. In many countries or developed countries, they already have they have very high or expensive taxations for the old car, because it can shift people not to have the old car because it's more expensive than having the new and better ones. But so policymakers should consider the increase in tax and fee for the renewal of old vehicle registration gradually, so that the public feel less affected and burdens. So for example, in the first phase, we can set the tax fixed tariff from the first year and abolish the tax rate cut for active vehicle over 5 years. So you can have like afterward, you can gradually increase the old car tax rate and announce in advance to make public understand that why old car tax should be increased. Then also adding an old car management systems to manage the end-of-life vehicles or the old car control policy options. So we need also have the guideline for end-of-life vehicle management. So currently, also Ministry of Industry appointed a working group to study end-of-life vehicle management, and also in the process of developing the guideline for end-of-life vehicle management in Thailand, which is very important. So if we would like to remove the old car, we have to find a way how we manage the old car properly. So we need to also integrate all relevant authorities responsible for the end-of-life vehicles management systems in order to enable business involved in the end-of-life vehicle management to be operated sustainably. I must say that this could be also an opportunity as well, that we can have the market of this end-of-life vehicle management and also have some materials recycling in the vehicles industry as well. And another application is about EV conversions, bring old car into electric vehicles. So we can also modify or convert the old cars or diesel-based cars to be EVs. But in order to implement this measure, of course, that we need a lot of research and development of electric vehicles conversion, which I think this is also one of the futures industry as well. That recently I also seen that they are starting to have like EV conversions in different area as well. And promotion of the use of electric vehicle conversions by relying on the registered old car market based on like 41 million vehicles. We have huge market opportunity here. And develop market prototype for converting old car into electric car. And along the way, we have capacity building in both technological and production skills to transition toward electric vehicle manufacturing. So although I say that having the new passenger car, electric car, have less benefit, but if you change the old car to be electric car, it can have huge benefit in terms of the health impact reduction. And redemptions of old car for EV car. So like, just change of the old car to have like some reduction price for the new EV cars. So we can have viable approach of trading old car for new EV cars. And the impact of measures should be like studies in all dimensions as well. Then all agencies involved must listen to opinion of all stakeholders to come to clear conclusion and set plan, including the homologation schedules. Then development of plans to support procedure for trading of the cars, like disassembling, recycling, and other relevant supporting process are important to be in place before you having this policy. Or else, if you have policy of this, like changing the old car with the new car, and afterward, you have no way to manage the old car. So it's going to be in trouble. So it's important to have infrastructures development as well. Policy option 3, installations of the diesel particulate filters, which can have the economic benefit up to like 6,200 million Thai baht, and also have the can reduce health impact around $9,300. But in reality, in order to have the successful of DPF installation and implementation, you really need to have a good maintenance systems. And sometimes this is also one of the important limitation of these policy options. So currently, PCD or Pollution Control Department is in the process of implementing a pilot program to test possibility of installing DPF in the road transport vehicles and assess possibility of policy option as a measure to be adopted in Thailand. So we are also coordinating with PCD in order to update with these policy implementation measures. Because of course that this measure that we study is also existing, and we try to envisage and try to make the implementation faster and more effective. And in fact, retrofit the TPF could be also like help with the old car, should be first imposed on controllable diesel vehicles. So for example, if you have planned on retrofit DPF with private passenger cars, which have like huge amounts in the areas, it's more difficult to be controlled because it's based on individual vehicles, and the maintenance checks it will be more challenging. So it have that's why this reason we would suggest to also apply to larger fleet. For example, like bus, trucks, and then also on the company-based vehicles that could be tracked and verified and maintained properly. So these could be the first sectors that we can implement. Policy option 4, use of low sulfur fuels lower than 10 ppm would lead to the economic benefit 4,000 million baht and also health impact reductions $6,000 in BMRs. So this is also the good news that in this policy option we already have the all industry that involved in the stakeholder meetings as well as also the seminar previously. They are already ready to have this policy implementation in January 1st, 2024. So we already enforce, and we believe actually because anything can happen because it's 2022 right now, so you never know. But based on the current industrial engagements, we found that all industry are ready to make the change according to this time. And we try to push that, can it be faster? Yes, because of Euro 5 and Euro 6 standard also linked together with low sulfur fuel. So that's why we try to ask industry, can it be faster? So many factory or some certain company are also ready to have low sulfur fuel already, but the price is more expensive than the like typical fuels. So we can have also try to have the tax measure or some incentives to expedite the productions, to have the starting the production and sale of the sulfur fuel with low sulfurs before the plan. And the two companies like PTT Oil and Retail Public Company Limited also ready to distribute fuels with the low sulfurs during the period of air pollution. So currently we don't have the whole low sulfur fuel in all period, but during the high or peak season, we also have some different company to be a part of this air pollution reductions. Sorry. Then the next one is the option 5, setting up low emission zones. So based on our scenario analysis, that if you have banned the diesel passenger cars, it can have even higher benefit than the truck ban because it have like more passenger cars in based on these inventory development models. Then we can lead to the 4,700 million baht of economic benefit, but truck ban we have only like 3,000 million baht benefits. So in this one, it can have like, for example, we have the diesel cars around like more than 2 million diesel cars, but for the truck, we have around like 0.1 million trucks in BMR regions. So that's why in this case, it's just quite obvious that not only truck ban, but also different type of ban is also can be effective. But so what? Yes, the next question is that you ban car, but again, you need to commute, right? The car is for transporting people or goods to certain locations. So we need to have alternatives. So having these options alone, it is how can you call theoretical, very theoretical, because of we need to have the other alternative for passengers transport and good transport to be in different options. For example, if we would like to implement diesel passenger car ban, it means that we need to provide other type of transportation for the people to commute around the low emission zone area. For example, we need to have better public transportation. The effective public transportation is important before having this one. Or else people will have no choice. Then we need to have, they still have to commute or transport to a certain area. Or the truck ban. If we ban the truck from delivering goods in the area. And of course, if one truck change to be 10 vans or like 10 pickups, I think the emission might be the same and the impact will be not reduced. So in order to implement this policy, we need to really have the consideration of the alternative as well, that what would be a viable alternative for people to commute in the low emission zone. And also before enacting this policy, additional study also conduct as well, need to be conducted, like determine the cost effectiveness of enacting policy to have adequate economics, health, and other benefit to people, and allowing stakeholders to participate by welcoming opinion recommendation to formulate policy appropriate to the transport sector Thailand. And the opinion that I just gave you earlier, we also got it as well from the stakeholder engagement activities, that this is also important. Of course, that anyone would like to have low emission zone, but it's important to have alternative in that area. And some of the projects that existing in BMR, like Clean Air Road project, also included in the Bangkok government action plan and require responsible agencies like to increase green space, having the monitoring and controlling air quality to meet standards, traffic management, and also like relevant agencies strictly enforcing law according like against non-standard and polluting vehicle drivers, raising public awareness and increasing the frequency of the road cleaning. So these are some clean air road projects. It is not actually accepting the like low emission zone, but it is the current policy in Myanmar. Then the next policy option is promotion of electric vehicles, which you can see that is based on these studies that changing passengers like passenger cars, motorcycles, and bus to be the electric vehicle is still like showing some limited economic benefits. We will still have to identify that because this one is the change of the new registration vehicles. But again, majority of the car or vehicle on the road right now are the like older vehicles. So we have to identify that how can we change the old vehicles to be the better one, or like have EV conversion or have some the improvement of old vehicles. But of course that regarding the implementation measures of the EV implementation in Thailand, we also have like, they also support public use of electric vehicles instead of this two main approach. First is reduction of import tax on electric vehicles from abroad and establishment of a fund to subsidize price from some electric vehicle buyers. And then also having also like support in terms of R&D of electric vehicles in Thailand as well. Lower taxation of electric vehicles than that of general diesel vehicles. So that is important. That people who buy electric cars should gain benefit than typical diesel vehicles. and promote electric vehicles under like 30-30 policy to set up goal to produce zero emission vehicles to achieve at least 30% of total automotive production by 2030. But if you remember that, I mean, in this scenario, we already have the 50% new registered car. We still have like very challenging. How can we really tackle with air pollution? And of course that in order to have proper infrastructures of electric vehicle, both for the newly registered one as also the old vehicle one, increasing electric vehicle charging stations to make them more accessible. This is also important. And set goal to support the development of the public charging station to meet the demand needs and subsidize support tariff for charging station. So these also part of the implementation measures that we would propose in the electric vehicles. And of course that have the support charging station, right? And raise public awareness for like disseminating knowledge regarding electric vehicles and support business operators, research and technology development, not only to buy or import the vehicle from abroad, but we need to build up industry in the country as well. And you see that this is also big business opportunities in our countries. Encouraging, incentivizing small people to decide to use electric vehicles, and also studies reasonable tax rate, which is the best interest from all parties. Government should not lose revenues and people should be benefit from the policy enactment at the same time. So this is also one of the concerns that we obtained. The last policy option is on promotion of electric buses, which could lead to the economic benefit around 306 million baht, which is still like have the least benefit as well. So this is also one of our concern that because of the current buses still not the majority. For example, you have 2 million of passenger car and you have only 13,000 of public buses. And if the public, this one is based on the bus registrations in BMR, the actual numbers of vehicle might be reduced than this. So the actual benefit could be reduced than this. So we need more buses. The high quality buses with low air emissions that will be needed. So this one also one of the promotions that we would like to promote. And efficient government support policy and integration of all sectors to encourage electric bus. And in fact, the Bangkok Mass Transit Authority or BTMA has already introduced structural measures in 2021 with the plan, but again the plan has been postponed a little bit, but it's there based on our last discussion that it will be implemented and it's already have the budget to rent the total in terms of like 4,000 electric vehicles to be run by BMMTA. And develop prototype electric bus projects to develop electric bus from used bus from BMTA. So a part of like renting, also develop prototype and then also having the like Thai-made car. That could be also done in other countries as well because it's one of the good industry. And one of the most important activity, I must say that all of this work have been developed together first with also student research. I think many of you now are the bachelor students and also like some graduate students and also some from universities and some from industry. But based on registration, many of you are from university, right? So I would like to inspire young students to think about all of you can do it. This one originally it has been developed by a master student thesis, and afterward we work together with business sector stakeholders to develop policy report, and we try to implement to like dissemination of our knowledge, networkings, and then try to really push forward. Of course, that the clean air solution cannot be implemented by a single person, but it could be implemented together with the networking. So I do hope that today event could be a part of the push forward, for the clean air solution, not in Thailand, but also in other countries in our region as well. So before finishing my presentation, I have to thank you for the funding agency, of course, that I want to thank you, National Science and Development and Technology Development Agency, NASDAQ, to research grants, made on universities, as also the life science Life Cycle Initiative hosted at UN Environment for giving this support from the papers and the white papers on PM 2.5 and health impact reduction options. And also this seminar have been supported by the Policy Advocacy Grant 2020 Mahidol Universities. And thank you the research teams. So Pacharakon Sakpeng, Akiti, Dejas, Chanakon, Sukuman, and Sukunon Chanawes, as well as also Professor Shabir Kiwala, who are also in this seminar today, that being a part of this all developments together. And this is a part of the work. In fact, we also have PM 2.5 footprints for the public to be able to use this tool to assess potential impact of your transportation choice in Thailand. Sorry, now it's not in the global base yet. So we developed this tool for support decisions of the public to decide which transport could have the lowest impact. So this part of the work that we deliver and have their like infographic and information to the Facebook as well. So thank you everyone. And sorry that I spent a little like longer time than the plan. Yeah. So now we have time for the discussion together with the all speakers and stakeholders. Yeah. Yeah. Before we having the discussion, can we have group photo first? Just in case that I'm afraid that maybe like some may have to leave first. So it would be very nice if we can have like if you are kindly turn on your camera so that we can have the like memory together for today. So I would like to ask my team to help capture the pictures. Professor Wongpan, are you available? Dr. Memon, Dr. Mustaq, could you please turn on your cameras so that we can have photo together, please? And just for giving you some information that we will start like, I mean, one by one can have a discussion first with Dr. from Evelyn, and afterward with Dr. Mustaq, and then Dr. Wongpan and Professor Wongpan.
It's to me, sorry, the voice was like little.
Oh, can you hear me?
Yeah, I can hear you, but it was a bit slow. Let me put my volume on. So, yeah, can you please repeat?
Yes, we will take a photo first, and afterward we will have the discussion sections by having the Q&A from different presenters. So I will just take a look in the chat box, and then you see that whether we have some the questions, specific questions to the speakers, and later on we also like, if possible, I would like to ask the speaker to give some short, how can you call short information that what would be the factor that you think this is the most important factor that make clean air solution being successful. So
important factors that making the air pollution, the last words.
Yeah, the important factors that make the clean air solutions implementation being successful.
Okay, successful factors. Okay.
Yeah, success factors. And
okay.
In fact, it should be like success factor and failure factors. So, but again, we have limited time. So I would like to go for success factors then, that we can have many failure factors, but now just think that what would be the most important success factor in your opinions? Okay, so you ready? So for cameras, the team ready? 1, 2, 3. So if you finish taking photo, please let me know. Okay. So thank you, everyone. So then let me shortly see from the chat box first that what do we have the questions. Some questions have already been answered by Evelyn. Thank you very much. Yeah. Okay. I'm just thinking that currently we have not that much patience. Some questions already been answered. I think one of the question that being asked, okay, Evelyn asked me regarding specific measures being done to address very old vehicles. That is controversial issues right now. So that's why I changed the policy option from banning the old car to be how to manage the old car in a better ways. Because we cannot ban the old cars, because it has huge effect. So how can we really make the old car being better in this case? And regarding the policy option on sort of electricity generation for the electric vehicle, so that is also important question as well. So we have to work together as well, not only like to change electric vehicles, at least it's you have to also control onto the source of electricity production. But currently in Thailand, we have also like majority of the electricity also from natural gas. So and we also have the plan for renewable energies and have a high percentage of renewable energies in also like Thai electricity generation as well. So in this case, we have to also work together with the electricity productions. But still so far, when we include both fuel productions and fuel combustions, the electric vehicle in Thailand is still better than the diesel-based vehicles. So this one, in this case for the study regarding the establishment of low emission zone was the impact of air quality. This is a zone where emissions were diverted to be also models. In fact, based on my analysis for my research, for my team research, we have modeled the banning the car to run in the Bangkok area to be in other provinces in BMR. So emissions remain unchanged, but the change are the health impacts because of if the car running to the less populated area. So in that case, the effect gonna be less. But the problem is that, of course, the residents and occupants in that area will be more affected. And that is also like, you know, not in my backyard as well. Yeah, so somehow, for example, if I have this policy, not running in Bangkok, but run in Nakhon Pathom, where I'm located right now. So I feel like I'm not fair right now. But if you look at total health impact, it can be reduced. But still, the best thing is like low emission zone, it's rather not to move car from one place to another place, but we rather have to identify alternative transport systems. So public transport infrastructure very important for the successfulness of the success of the low emission zone implementation. This is based on my opinions. Yeah. So regarding low emission zone, what would be your Dr. Wong, Professor Wong Pan, are you with us right now? Okay, I think.
What was the question?
Yes, what would be your reflection on low emission zones in terms of the health impact reductions?
Well, our approach to the low emission zone is not to restrict vehicles entering the emission zone and put the burden on the surrounding area, but rather encourage people to use the low emission vehicles having higher standard of emission. So they can still enter the low emission zone, but for those with low, not up to date emission standard, they will have to pay a sort of pollution fine. For those that have up to date emission standard, they won't have to pay, like in the London, where the low emission zone will be open to the Euro 5, Euro 6, but for those Euro 4 and before that, they have to pay the pollution fee, something like that. So So in this effect, we are not really put the burden on the surrounding area.
And I think it's also like, I can also a little bit like modify my white paper as well. Yeah, this will we include as well, that it's not just moving the car from one place to another place, but this low emission zone could be implemented as a policy to change the vehicles, right? To make people feel it's more difficult when you use the bad cars, because there are low emission zone in many places. So it may be more expensive. So instead of putting tax directly, so try to make it more difficult to use the vehicles with the higher pollutions. And in this one, people you can see also like clear picture that okay, you pay on what you pollute. But I think it's also implementation is to have many challenging issues as well. Okay, then we also have like include organic component of PM 2.5. Thank you, Dr. Mustaq. I will try to also include this in the future as well. But of course, that there are some certain limitations of the research methodology as well. That what we can do right now. Yeah. So I would like to ask Evelyn Tamayo to help like give some short like, or could be like, what could be the important factor for you that can we implement clean air solution successfully?
I think in our context, also in experience working with national and local governments across Asia, the challenge is that some measures are not applicable if it's applicable and effective in one country or city, it doesn't necessarily mean it's going to be effective in the city we're working on. So the success factor is really discussing with the stakeholders what is really realistic and applicable in the local context, because otherwise pushing for measures that they wouldn't be able to comply with or they don't have the capacity to implement it would just pose additional workload and stress as well, and it wouldn't inspire them to do the measures and see the improvement later on. So it's very important that there is local context understanding and always discuss with the implementers and those that will be affected by the new measures or policies.
And may I ask that what is the current status in your opinion in Manila? Whether the implementers also like supportive, or then whether the policy option will be implemented in the future?
It's very promising in the sense that there is, especially for example, the transition to non-motorized transport, especially with the pandemic. So it also affected the mind view of people of wanting to biking more or walking instead of taking public transport. But that's also a problem because right now it's very difficult to promote public transport in the context of sharing vehicles with strangers or other people. Another important, so it's another challenge as well, so that is also a factor, is that if in the city of Manila, it's a very congested city. So for example, low emission zones would be very difficult to implement because everything is with high population density. And also there are sometimes roads that are under the jurisdiction of the national government. So it's not the responsibility is not just on the local government. In terms of EVs, there's also growing interest, but what has to be addressed would be the market policies on how will the EVs be evaluated and allowed into the market. So this is the registration process. So this is something that there's a lot of talks, but there has to be more concrete measures to make it more accessible for everyone. So also to say the governments are very interested to push through it, but it's the tiny details, and we try to guide them so that what they're doing is also aligned with national efforts or national agencies.
Okay, thank you. I think perhaps if you wouldn't mind, maybe the next 6 months or maybe next year, we can have seminar again to see that whether what we talk today is implemented next year. Yeah, or what's going on, like to wrap up and then try to move forward. Yeah, thank you, Evelyn. So next, I would like to ask Dr. Mustas that could you please give some highlight, successful factors for clean air solutions?
Okay, I think the successful factors is a combination of what we call the carrot and stick. Means you have the rules, like suppose in Singapore, you have a congestion charges, but then you have to provide the better access, like public transport. So people can feel that if they are losing their cars, at least they have a better alternative there to move and more effectively. So same like Bangkok, we saw BTS, and now even we saw the BTS up to Rangsit and so on. So there's a lot of so on the one hand, you can increase the pollution pay principle like base fee. For that, anything is transport. I just gave you example, but it can go to the industries, it can go to the waste management, anything. But so the point is that on the one hand, you enforce the rules, but also you provide the better alternatives. And then also you provide the pride. Now, suppose now is social media, no? So like a lot of groups and everywhere. So suppose I can recycle, I reuse, and say no to plastics and so on. So the point is that people get now pride into that. Like in the past, the pride was owning a car. That if I own a car, it's my pride. But now it's moving to the like a shared cars and so on. And also there's in the past, if you see many people used to live outside the city in suburbs and own 2-3 cars and commute. But once we have a lot of now smartphones and all this, people do not want to drive. So they want to use their smartphones. So the culture is also changing with the new technologies and everything. So as I say, now the taxis are easy with the shared economy also. So the whole point is that you look in the holistic framework to use the carrot and stick in a way that it helps positively. So I think this is a success we have seen in Singapore, or now even in Bangkok, we are seeing it. So I think that's the good thing.
Thank you, Dr. Mustas. So next, I would like to invite Professor Wongpan to give some highlight, sharing about the successful factors. Okay, I think maybe he's missing a little bit. So yeah, so for me, I think I already in line with Evelyn as well as also Dr. Mustas as well, that regarding stakeholder engagement is very important. I think it's the most important key factors that you have to ensure that we have include all stakeholders in order to make and have to provide. First we need the knowledge to understand the effects, right? And after we have the knowledge, then we need to also engage with stakeholders in order to implement the policies. And for example, like rule enforcement or legal enforcement with better and affordable alternative also important. Many options that we provide is not applicable because at the end they don't have other choices. So we need to provide choices which are affordable. So I think that would be very important. But so far, based on what I have seen and then what I have worked for the past 3 years in this regarding health impact and health cost, I have seen the movements and then the networks in different regions of Thailand and also in different countries. So I think with these type of activities, networking activities and engagement nationally, locally, as well as internationally, you help also to promote the clean air solution successfully, not only in our country, but also in other countries as well. Yeah. So in my opinion, what we are doing right now is on the right track. And we do hope that this event is like one of the activity, but of course, it's not be the last one. We will also continuously having this type of activity and sharing the success case as well. And try to say that what would be the better one in the future. and move forward with the policies. Yeah. So today, if you have some other questions or concern, also feel free as well to contact me. I think everyone, when you register, you have seen the email as well. Yeah, feel free as well that later on I will send you the slides and the material from speakers. So also maybe within 1 week for the slide, but for the white paper it's a little bit longer time. So when it's ready, we'll send to you all. So I hope that we all keep connected and so that we can move forward together for the clean air in our region, our countries, and our world. So thank you very much, everyone, for today. So bye-bye.